Okay, so 3-4 talks about arc length and area of a sector. So remember from, I believe it was 3-2. Oh yeah, it says it right there. It says that we defined radians as arc length divided by a radius. Remember that? Well, we can rearrange this guy depending on what we want to find. Okay? So if we want to find an arc length, we can multiply our radians or our angle by its radius. Or if we want to find a radius, we can take an arc length divided by a central angle of theta radians. Okay? The trick is to find one of those 3 versions and memorize it. Okay? To be honest, this is the one that sticks in my head. S equals R times theta. The other trick that we have to know is that theta is always in radians. Always. So if it's not in radians, then we have to convert it to radians. Does that make sense? Okay. So, number 1 there says, find the arc length, or the length of the arc S, if the radius of a circle is 4.3 inches with a central angle of 2 rad, or 2 radians. Okay, so they gave me S. They gave me, or no, I'm looking for S, sorry, find the arc length S. They gave me the radius and the central angle. So S equals R times theta. My radius is 4.3. Theta is 2. .3 times 2. 8.6. So that's 8.6 inches. Remember, that would be like a chunk of the circle. Okay, number 2 there. The minute hand of a clock is 1.2 centimeters long. How far does the tip of the minute hand move in 20 minutes? Oh dang. Okay, let me draw you a picture. Here's my clock, right? Let's just say he goes from here to there, right? That's about 20 minutes. So I want this. There's the tip. The tip is moving from here to here. And it's 1.2 centimeters. So did they give us an angle in radians? Did they give us an angle in degrees even? No, they didn't even tell us that, right? They said 20 minutes. Well, how much of a rotation in a clock is 20 minutes? A third, right? So we're going a third of a rotation in 20 minutes. What's a full rotation in radians? 2 pi, right? So I want a third of 2 pi. Or 2 pi over 3, right? Okay, so there's theta. We've got R. So S equals R times theta. So 1.2 times 2 pi over 3. Because 1.2 is a decimal, we can go ahead and put that pi in our calculator. So 1.2 times 2 pi divided by 3. How far is that minute hand moving? 2.5 centimeters. Yeah. If you want to leave it in exact, that's okay with me too. Okay? Exact, remember, is with the pi still in the answer. If you're going to put pi in your calculator, make sure you use the pi button and don't type in 3.14. All right. Number 3. All person standing on the earth notices that a 747 jumbo jet flying overhead subtends an angle of 0.45 degrees. If the length of the jet is 230 feet, find its altitude to the nearest 1,000 feet. What the heck does that say, right? Okay, here we go. I'm going to draw you a really pretty picture. And you guys are going to be like, wow, you should have been an artist instead. Because you already think that, right? You're like, dang, why'd she become a math teacher? Because art is totally her thing. Right? Look at my jumbo jet. Wow. So good, right? Okay. So this person's looking up, and it says from the front of the jet to the back of the jet is, that he knows it's 230 feet. So that's my arc length. And this little angle down here is 0.45 degrees. It wants to know how high is that guy off the ground. What altitude is it flying at? Does that make sense? Okay, so a few things. We're looking for the radius. What about that 0.45 degrees? We got to go to radians, right? Every time we use theta in our formula here, we have to go to radians. Okay, so we have to take 0.45 degrees to radians. How do we convert to radians? Anybody remember? Is it 180 over pi or pi over 180? Pi over 180. Here, hold on, let me show you. Degrees to radians, pi over 180. Okay? Alright, now, 0.45. I'm going to actually just, remember we talked about reducing that guy as a fraction? So let's do 0.45, because that's pretty nasty, over 180. See what good old calculator here gives us. Well, that's grody, right? 0.0025 pi. See if she'll take it to a fraction. She can do it. Pi over, look at that, pi over 400. Now, in this instant, if you did 0.0025 and then multiplied it by pi, because we're all the way out there in like 4 decimal places, I'm okay with you using a decimal. Let's just go ahead and multiply by pi and see what happens. 0.0079. Alright, so we're looking for R. S equals R times theta. So R is S divided by theta. So 230 divided by that 0.0079.
It's a lot.
Oh, sorry.
29,000.
29,284, right? 0.5. Excuse me. Yeah. probably because I did the answering here. So I just grabbed this guy. So if you did 0.0079, you're probably going to get something different. So if we do 230 divided by 0.0079, yeah, you're going to get something different. Okay, which brings me to a good point. How many significant figures did our problem have? 3. Technically 3, right? 2 to 3. So we could say this guy is 29,200 feet or something like that, depending on here. So we could just say 29,000 as well. Does that make sense? So depending on how you carry it through your calculator with the pi. I'm good with either. Okay? Again, that's why it's good to show me what you're doing in your calculator and the steps you're doing so I can give you partial credit. Yeah. Okay, questions on those? Are you good with all of those? So you need to find some version of that formula that you like and remember it. Like I said, I remember S equals R times theta. That's just what's in there from way long time ago. Okay? Then I just rearrange it to find what I need. We could have also put it in here and then just solve. Does that make sense? Okay. So the other thing we need to talk about is what a sector is. So a sector is a pie-shaped portion of a circle. Normally what we do is we find the area of that. Think about it as a piece of pie or a piece of pizza. No, not like PI, 3.1415, all that jazz. Think about it as like cherry pie. Does that help? Okay. Yes, good question. So it's like a piece of pizza, right? That's a sector. We're just going to take a chunk of it and take it out. And sometimes we find the area of that or all sorts of things like that. Okay, so way back in geometry, it was a very long time ago, right? From geometry, we had a formula that talked about the area of that. What's the area of a circle? That would be volume of a sphere. How about I cut you off, I'm sorry. Pi r squared, right? Okay, so if we're talking about a full circle, the area was pi r squared. But then we said if we're not talking about the whole circle, we're going to take whatever our degree is out of 360, right? So we could get like a chunk of it. Say it was 120 degrees, right? Our central angle was 120 degrees. So we multiplied it or divided it by 360 so we could figure out a portion of the circle. Does that make sense? Do you remember that formula slightly? It's okay if you say no, I don't care.
Yes.
Thank you. So this from geometry was the area of a sector. But this guy right here is in degrees. And everything that we've been doing so far has been in radians. Okay, so what is 360 degrees in radians? 2 pi. Okay, so really our formula should be theta over 2 pi times pi r squared. What happens to that bad boy? There's a pi in the top and a pi in the bottom, right? So could we get rid of them? You bet. Theta over 2 times r squared, and this is how I usually write it. 1/2 r squared theta. So if you're looking for the area of a sector, oh wait, friends, sorry. We get 1/2 r squared theta. Okay, so again, we're still in radians. We got to keep with our radians going on here. Oh, and so it said by replacing 2 pi for 360, we can get this. Bloop. All right, so let's try number 4. So let's find the area of the sector formed by a central angle of 1.4 radians in a circle of radius of 3.2 centimeters. Okay, so my formula. This one you need to know as well. 1/2 r squared theta. All right, so we're looking for the area. What's my radius? 3.2 squared. Theta, thankfully, is in radians, so I'm going to just put in 1.4. Are you done with that one?
Yeah.
Okay. Let me do a quick double check on it. Yes, much better. Okay. Do you need a calculator?
I have
Okay. There you go. You're welcome. Let me know if you have questions. All right, so let's put this bad boy in our calculator. I'm gonna do 1/2 times 3.2 squared times 1.4. Oop. I didn't want that, I meant to push enter. That guy. So 7.168, or if we keep with sig figs, 7.2 centimeters squared. Remember, when we're dealing with area, it's square units. Okay, number 5. Are you okay with that? Okay, good. If the sector formed by a central angle of 15 degrees has an area of pi over 3 centimeters, find the radius of the circle. All right, well, it's all fun and games, right? Till now they give us the area and tell us to find the radius. What's my first thing I have to do? Convert it to radians. Oh, you guys would make me so happy. 15 degrees to radians. Here we go. How do I convert to radians? Times pi over 180, right? All right, let's leave him exact. So 15, whoa, oops, 15 over 180 reduces to 1/12, so this guy is pi over 12. And I'll show you why I want to leave him in exact in just 1 second. Okay? Alright, so here's my formula. Remember, my formula is 1/2 r squared theta. Well, they gave me the area is pi over 3. They say find r squared, and my theta we just decided was pi over 12. Okay, so let's clean this side up here a little bit because it's a little gnarly. So I got pi over 3.
Can we also use our unit circle chart and just divided the radius of 30?
You bet. Yes, that's awesome. All right, so I have half times pi over 12. So this guy is technically r squared times pi over 24. Would you agree with that? Are you okay with that? Okay. How am I I gonna get rid of this bad boy here? How do I divide fractions or get rid of fractions? Copy dot flip, right? Multiply by the reciprocal. So if I multiply this guy by 24 over pi, and I multiply this guy by 24 over pi, well, those cancel. What happens over here? The pi's cancel. Well, hey, that's pretty nice, right? I've saved myself a whole bunch of work with crazy pi decimals. So then I have 24 divided by 3. 8. Awesome. This guy's not too bad. So I get 8 equals r squared. Take the square root, right? All right, now we're dealing with a circle. So technically, remember, when we take the square root, we get a plus or a minus. Do I want the minus right here, though? No. So if you want to leave it an exact value, it would be 2.2 centimeters. Or if you like it as a decimal, let's see what we got going on here. 2.8 centimeters. All right, you ready for the last one? This is like my life right now. I was doing this the other day. A lawn sprinkler located at the corner of a yard is set to rotate through 90 degrees. It will project water out 30 feet. What is the area of the lawn that is watered by the sprinkler? Okay, so here we go. Here's my sprinkler. It starts here and then it sprays like this. And it projects water out 30 feet. All right, 90 degrees. What do I have to do with that? Convert it to radians. As Harry said, he just can use a circle, right? So it's 90 degrees in radians. Pi over 2, right? 1/4 of 2 pi. Remember, you can multiply by pi over 180. So pi over 2. And now we're going to plug them into our formula. 1/2 r squared theta. 1/2. My radius is how far the water's shooting out. Times pi over 2. You can leave your answer in terms of pi if you'd like. I don't care. Okay, so if you want to leave it in terms of pi, that means you don't put pi in your calculator. Let me show you what that looks like. So if you don't put the pi in your calculator, 1/2 times 30 squared times another half. So you get 225 pi. Does that make sense? You can leave your answer like that. You can say it's 225 pi feet squared. But I don't know about you, that's a little misleading in my brain, right? So if you would like, you can also multiply that pi out. 706.9 square feet. Or 706 square. 707. 700. 10. Okay, does that make sense?
How did you get this?
I multiplied it by pi. So when I put this guy in, I didn't put the pi in there. You could put the pi in and do it all at once if you want. Yeah, so I could have done this. And if I just replace this guy by pi, there he is. Yeah, and I'm okay with that. Okay, questions on any of that? I don't feel like that was horrible, right? Was that a good last day of Algebra 2 trig notes?
Yes.
Yes, yay! Guess what? You're all done taking notes forever with me. Some of you are gonna throw a party. Okay,